Okay, now let's move on to the structural questions here. Okay, so for the first one, first question asks you to calculate the molarity. So this one pretty straightforward. You get the mass, then you will be able to work out number of mole, okay, because the molar mass is given. So first step, you work out number of mole and then divided by its volume. So this one, remember the volume is in cm cube. So you need to convert the unit to dm cube, okay? Hence it will be 0.2500. And then the answer, okay? You can take two significant figures or 2 dp, okay? I will give you mark for that. So that's for the first one. Most of you did well on that. And then for the next part, okay, it states the pH of that 0.06 molar potassium hydrogen that thing solution is 3.3. Okay, and then based on the information, comment whether it's completely ionized or not. Okay, there are two ways of doing it. Because you know the concentration, okay, so let's assume it completely ionized, then we can work out the hydrogen ions concentration will equal to 0.06 molar. Then by using that, we can calculate the pH, which is 0.122. Okay, a lot of you have done that step, but then you skipped one step and just draw the conclusion. Okay, you need to compare this number, the number you calculate, because 1.22 is much lower than the values that actually being measured, which is 3.3. Hence, it shows that this solution, this compound, is not completely ionized in water. Okay, only partially ionized. That's one way of answering this question. Of course, you can work it backwards. Okay, so because you know the pH, and then you be able to work out the concentration of hydrogen ion, which will be 0.0005 molar. Okay, which is much lower than the stated concentration, 0.06 molar. Hence, it's stated is only partially ionized in water. Okay, so make sure you do the comparison and draw the conclusion. Okay, so that's very important for this one. If no question for this, I'll move on. Next question. What should express this concentration in mole per dm cube? Okay, a lot of you made mistakes for this one. Okay, not doing the calculation but converting the unit. Okay, so for this one, the question give you the concentration in gram per cm cube, right? It's in cm cube. Okay, so first we can convert it into gram per, into mole per cm cube. Okay, remember the formula that I asked you to memorize for this unit. Okay, so ignore the model answer provided for you. I'll write the rough work here. So at the beginning, we got this 1.0 times 10 to the power of 8. That's in gram per cm cube. Okay, so how to convert that into mole per cm cube? We divide it by its molar mass. Okay, the molar mass will be 207.2. Okay, and by putting that into calculator, you can get this number. That's in mole per cm cube. Okay, so many of you can achieve that step, no problem at all. But the next problem is, how do you convert from mole per cm cube to mole per dm cube. Okay, a lot of you divided by 1,000. Okay, so think about it. What's the meaning of this unit? Okay, mole per cm cube. That means if we have 1 cm cube of that solution, we will have 4.826 times 10 to the power of minus 11 mole. Okay, if we want to have the unit in mole per dm cube, that means we need to express the number of mole in 1 dm cube. So which one is a larger unit, cm cube or dm cube? So of course it should be dm cube, which is a larger unit, isn't it? So you expect this number to be bigger than this one, isn't it? So here we only express the number of mole in 1 cm cube of that solution. But on the right hand side, we need to express the number of mole in 1 dm cube of the solution. Okay? In more solution. Okay? And actually it's 1,000 times more than this solution, isn't it? So the way that you convert it from here to here, you should multiply by 1,000, not divided by 1,000. Okay? So by converting this, you should use this number, multiply by 1,000, and then you will get the answer expressed in molar, which is mole per dm cube. Okay? Make sense? Okay, so if no question, I'm gonna move on to the next one. Okay, this one, observation. Just need to state gas bubble forms. Okay, and then the ionic equation. Most of you get this correct. So just a hydrogen ion to react with this hydrogen carbonate and release water and carbon dioxide. Remember, this year, whenever you are asked to write ionic equation or chemical equation, make sure you write the same symbol. Okay? And next one, question 4. Okay, calculate the molarity of the sulfuric acid in the solution. Again, it's a pretty standard question. You are given the mass and also the volume. So you just need to work out the number of mole first. Mass over the molar mass give you number of mole. And then the molarity would be number of mole over its volume. Okay, so here, I think I didn't point it out in the when I go through the lesson in the video. Okay, so molarity only refer to the concentration in molar, so mole per dm cube. If the question asks you calculate the concentration of the sulfuric acid, then you can directly use the mass to divide it by its volume. Okay, so concentration can be expressed in gram per dm cube or mole per dm cube, but for molarity, only in mole per dm cube. Okay, so pay attention to the terms. Can I move on? Okay, then next one is a long question, okay, and asks you to write a lot of details. So if for normal teaching, I would set it as a practical test, okay, and you would need to do it on your own. But for now, due to the special condition, we can only go through the theoretical part first. So for this one, first the question asks you with the aid of a chemical equation. So of course you need to write the chemical equation, okay? Don't forget that part. And then you need to design a test that can show ammonia solution is a weaker alkaline than sodium hydroxide. Okay, so this question you need to do two parts. First, explain why ammonia solution is a weak alkaline. So you got the equation. Remember, use a reversible sign to indicate it's a reversible reaction. And then your explanation need to include those keywords partially or slightly ionize or dissociate in water. Okay, so a lot of the time later on you will find these two terms actually mixed up quite often. Okay, so no need to struggle with that. And then design the test. So there are a lot of ways to compare, and you have the table listed on your notes. So you can directly compare the pH, you can compare the electrical conductivity, the temperature change, so the energy released from neutralization. Okay, so these are the possible ways. And remember to state the expected observation. So for example, ammonia solution have a lower pH than sodium hydroxide solution, or neutralization involving ammonia solution will release less heat than neutralization involving sodium hydroxide solution. In the last part, you need to make a fair comparison. Okay, so for example, if you compare the electrical conductivity, you need to use the same concentration of the two solutions, and also you may use the same volume of the two solutions. Otherwise, the total number of mobile ions would not be the same. And for different tests, you need to mention different things, but at least you need to show the way that you make it into a fair test. Okay, so to show those control variables in the test. Okay, and you can see there is a thing called communication mark. So that's only appears in DSE exam. So you won't see anything like this in your IFY exam. Okay, so any question for this? If no, I move on to the next one. Okay. This one, again, pretty straightforward. Any safety precautions like wear gloves, wear safety goggles, a lot of the things. And then the next one, comment on the following statement. Okay, so you can mention there are two different concepts. Because there's only one mark, I don't want you to write an essay. There is no need to write an essay. Just mention, maybe just give an example, that would be enough. Okay. For example, ethanoic acid is a weak acid, but it can be concentrated. Okay. And the last one here, this one asks you to explain this observation with the aid of a chemical equation. So similar to the previous one. Okay, so first you need to write the reversible reaction to show that it's a weak acid. So that's a formula. Okay, and then it will ionize to give hydrogen. Actually, you would be, if you remember the formula for this part, only take a look at this part. There is one ionizable hydrogen, but now you got two COOH. So in principle, it can ionize to give two hydrogen ion. Okay, so the complete one should be the first one, but it's also accepted for the second equation. And then you need to state it's a weak acid. It will only partially ionizing water. Or again, you can compare the pH, or you work out the concentration to compare. Okay. And the optional question, so I want to go through it with you, this one. So for this one, I will write my calculation here. Okay, so the labels data for this solution, the density will be 1.18 gram per cm cube. And then the liquid contains only 36% of HCl. Okay, so by using these two pieces of information, we can work out the density for HCl in it. It will be 1.18 times 36%, isn't it? Okay, if we put into calculator, we will got the number 0.4248, and then it will be the same unit as the previous one, gram per cm cube, right? Okay, now the question asks you to express the concentration in mole per dm cube. Okay, so again, you need to do two things. First, you need to convert gram into mole. Second, you need to convert cm cube into dm cube. Okay, so let's deal with gram first. Okay, so by converting gram into mole, we just need to divide it by its molar mass. Okay, so it's equivalent to 4248 over its molar mass is 36.5. Okay, that's in mole per cm cube. Okay, so if you put in the number, it will be 0.0116 mole per cm cube. Okay, again, if we want to convert it into mole per dm cube, we need to multiply by 1,000. Remember, this number here means if we have 1 cm cube, we will have 0.0116 mole in the solution. Okay, if we express it in mole per dm cube, that unit tells us if we have 1 dm cube of that solution, we should have how many mole. Okay, so here we only have 1 cm cube. If we want to have 1,000 cm cube, then that becomes 1 dm cube. Okay, so we multiply by 1,000, that will give you 11.6 mole per dm cube. Okay, multiply by 1,000. Okay, so that's all for Unit 15 exercise. Any question for me? Or any question you want me to go through again?